All right. Hello, everybody.
Hi, everybody.
Go ahead and start us off.
Welcome, everybody, for learning Python through Minecraft. I am Alexander Preston, along with.
Hank Preston, his dad. And so we're going to start out with a really quick kind of introduction. This is going to tell you a little bit about himself and his interest in Minecraft and his interest in coding and some of the stuff he's done. And then we'll spend most of our time on a series of programs that we wrote using Python and Minecraft. And all along the way, I was able to teach Alex all programming skills. We'll see what's in there. Together some references and resources if you're interested in kind of doing some of the same things with your own kids. Or if you are a secret Minecraft player at heart and you just want to do it yourself, that will go as well. So, a little about it.
Hi, everybody. I'm 9 years old. Right now, I'm going to 4th grade. So I started coding with a Raspberry Pi. My dad found out a website named Scratch, which you'll see what Scratch is in a little bit. Then my dad found out that I can do Python and Minecraft, and I was like, OMG, this is awesome. I'm interested how video games work, and I like watching my dad code.
He does. So I do a lot of coding and development for my job, and every day he would come in and ask what I was working on, and we would talk about it a little bit, and I realized he was interested enough, so I started gathering a bunch of stuff for him. And so you can see him there. He's on the floor in my office with a Raspberry Pi Top and a Python for Kids book, and he would do about 10 minutes, and then he'd get distracted and go do something else. What it was is what he wanted to do with me, and that's where the hook came through, was actually a bit with him. And as he mentioned, we started out with Scratch. Scratch is a really simple programming language. It's available on just about anything, but we first found it on the Raspberry Pi. What did we know about Scratch, and what did
So Scratch is for beginners. Really, it's like Lego blocks. Like one Lego block is an orange, one that says this, and then below it is like move 10 steps, which is like a blue one, easy to connect because underlay is a white line when you can connect it. And we started building games with Scratch for the first time.
And when we games, that was my favorite thing to do.
Like making the cheat codes.
He did. What is it with It's okay, laugh. It really was his favorite part. I couldn't believe that was what he wanted to do. And the people that wrote and a lot of the Scratch stuff realized that, and they put cheat codes right into the games and the walkthroughs. And so we dove right into those. The Scratch, I knew I was onto something. Because Alex with Minecraft, so many kids out there love Minecraft. Adults love Minecraft. Alex, why does it?
Well, what I think it is because really there's no limits. Personally, I like making redstone contraptions, like redstone's like working, like basically, or like wiring things together. I like making traps, for like grief or villagers or myself sometimes maybe. And I like getting ideas from YouTube.
Yeah, it was really interesting to me when I do just Minecraft on their own. All of these blocks, and they really do learn programming and logic and actions and how to put things together. And the real hook for me was when I recognized and heard about Python plus Minecraft connection, and was pretty what?
Awesome!
Awesome. It definitely was awesome as we went through. And so we dove in to learn Minecraft pieces. Oh, turn off one of them. Okay. Turn this one off. I can talk super loud, so hopefully that microphone will pick it up for the recording. And so when we build a Minecraft application in Python, Alex, what is the absolute first thing we always have to do?
We have to connect to Minecraft and code.
Exactly. So that was the first piece of every one of our programs, was actually connecting Minecraft to Python and putting them together. So Alex, walk us through the code that's here on the screen. What are we doing inside of this bit?
So first you have to import a file named Minecraft and import a file named block so you don't have to memorize all the block IDs. And then we made a variable called MC. And MC stands for Minecraft Connect. And then once you're connected to Minecraft, you can either ask it or tell it to do something.
Yep. What are some of the questions that we can ask Minecraft once we're connected?
Hey, what's this block underneath my feet?
Yep, you can. It's really that simple. Because you may be interested. What are you currently standing on? Because if you're standing in the middle of a lava pit, well, that's a pretty important thing to recognize that's there. What's something that we could tell Minecraft to do?
Hey, I'm right here. Now can I go right here?
Exactly. You can move your player around unsuspectingly as they go in. And so this was the first part that we did with Python and Minecraft. And I said, okay, I sat back and I realized that even at this part, Alex was learning some really important pieces about Python and programming. I'm trying to get him up here a little bit. Programming in general, right? We all realized that we can't write all of the code ourselves, and so he learned about importing so that we can use other people's code as we go through. Variables are fundamental to just about everything, so we started playing with those and functions. And then we just built on this as we went through. Our first program was where is our player? Finding out information like that. And so Alex, what is our goal in this very first program?
So first we have to find the X, Y, Z coordinates. X moving left and moving right. Z moving forward and moving backwards. And Y moving, jumping up and digging down.
Exactly. So when you're playing Minecraft, whether you realize it or not, every location inside of the map has these coordinates that are there. And so we can ask Minecraft what they are and then build up from that spot. And so in addition to just knowing our personal location, we wanted to figure out some information about our environment. So for example, we're going to move over here for a second. So let's pretend that Alex is our Minecraft character in the game. Now, if you've never played Minecraft before, every character is 2 blocks tall as they go through. And so we wanted to know, what is Alex currently standing in the middle of? Which block on your body here would we be looking at?
Let's say you cut yourself in half and your bottom part stays up because that's what you're in.
Yep. So what is his feet currently in? So we wanted to know what type of block he was standing in. What are the most common blocks you might be standing in?
Air, water.
Yeah. You may actually be standing in lava, so we can take actions. Once we knew what he was standing in, the next question is, what is he standing on top of? Now, from your perspective, right, we've got blocks. Which block are we interested in when we're talking about the one you're standing on?
Right below your feet.
Yeah, so we had to figure out how to determine the block under the feet. Now, what types of things could you be standing on in Minecraft?
Just about everything.
Yeah, you could stand on anything. And so we set out to build this program as we went through, and it's called the Where Am I program. And so we start out, they can see it there, we can see it here. We start out with a while loop. While true. What are we setting up when we do that in our code, Alex?
We are setting up a forever loop.
Right, a forever loop. So this program will run all the time as it goes in. And our first piece here is about learning our position. And so talk about what do we have going on here in the program?
So first we're making another variable called position. And position, basically, it gets the top position underneath it gets the top position that you're in. Remember I said cut yourself in half? There you go.
Exactly. Now we've got our position where we are, and so on the same program, but on a different slide, I love dancing at the slides, we go ahead and we dive in to figure out more about where we are. And so in here, we start out with these variables here, Alex. Air, water, and lava. What are we doing there?
They're making a list, and inside those lists are block IDs. So 0 as air, 8 and 9 as water flowing and just water, stationary. Lava and same thing except 10, 11.
So these numbers are really important inside of Minecraft. How did we know what numbers to use?
We got a file named mcpi.block.
And that comes along with the Python Minecraft library, or all the information about the different blocks that are in there. And so with that, we set out and we created this set of if and elif pieces. What was our goal here to go ahead and figure out?
There we have to figure out if we're standing in air, water, or lava. If we're not in there, then the block ID.
when we went through this, we figured the most likely stuff, or all we could stand in, would be air, water, and lava. And then we realized there were things that you might be standing in the middle of. What surprised us? What were we standing in that we didn't expect?
Snow slabs.
Snow. If you're walking around in snow, it actually changes the block you're currently standing in. So we didn't expect that initially as we went in. And so that took care of what we were standing in. The next piece is, what are we standing on? Which is basically the same program. It's just we change a couple of pieces. In this case, when we want to get the block ID that we're in, what did we have to change in our code?
We had to do y minus 1.
Right, to figure out the block underneath our feet. And that was our hint into some of the relative positioning we had to do inside of the program as we went in. And then the rest of it was basically the same thing, just checking the types of things that we're standing on top of. So let's see this program in action, shall we? Come on over, Alex. I'm going to switch us over here, and what we see is we've got the Where Am I program running in the corner, and then we've got Alex down here in the game. Go ahead and jump in that lava pool.
Ouch.
Yeah. As soon as he jumps in, we see that we sound that ow, 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 ow. You're in lava. And it's reacting immediately as the game goes through. And this was the first one that we actually wrote a program to go ahead and make changes for, so we could see what was going on. Now, we tackled out of this program, and I said, okay, did we actually learn anything about Python, learn anything about programming? And in fact, we actually learned quite a bit. We learned how to print out and format strings. We learned how to do lists and if conditions. So even in these basic things with his game, he was really coming to grips and understanding how the pieces went in. And then we decided to stick around with location, but rather than just where he is, let's do what?
Move your player around the world. Teleport.
Teleportation. At random, just start moving your person around the board. Can we handle that inside of the code? And so as we took it to this, we took a slightly nicer one. We wanted to tour our world, send the player out there. So how are we going to do that in the code?
So we were going to go 100x and 100z.
Yep, and move the player around. We thought this was going to be a fairly simple and straightforward program. We can do some basic math, change the position, but we ran into a couple of problems inside of the program pretty quickly. What were some of the issues we ran into in our teleportation program?
Let's say, I don't know, you teleport and you fall in lava. You would basically, chances are you would die. Mm-hmm. If you don't die, then you're lucky. Yep. Or if you end up inside a mountain, you're like, then it teleports you inside a mountain.
Yep. The code would actually let you reappear right in the middle of a mountain or a building in all those areas. So we started to dive into troubleshooting and changing our code along the way. And so for this example, let's take the landing on top of water or landing on top of lava. How did we solve this problem in our code?
We placed a block underneath our feet of obsidian.
Yeah, pretty simple. We gave ourselves a raft in case we landed on top of water or lava on that one. And so in addition, like, we sat back and we said, what did we learn? Well, we started with math. Was actually really interested in math, so it was pretty easy to put that into Python. But we show how we could actually add and subtract from the coordinates that were there. And then the troubleshooting and thinking through our problems. What do we do if we land in the middle of a lake? Right? We needed to solve that issue on our teleportation program. And then Minecraft is more than just walking around. It's also about building things. So in our third program, we tackled placing blocks. In our first one, we kept it pretty simple. What did we want to build?
A bedrock stack, 3 blocks high.
Yep, a 3-block high. That was simple, just a stack of bedrock. And so in our code here, we were taking advantage of a function called setBlock that comes along with the Minecraft library. And what did we have to provide to the setBlock function for this to work?
X, Y, or Z, and then the block you want.
Mm-hmm. And so let's go ahead and use our positioning here. So we're going to take Alex once again. And so how did we figure out where to place our blocks?
We use relative coordinates. So let's say I'm right here. I want 2x away from me. So 1, 2, as you see.
Excellent. All right, so we go 2 over. So that gives us the 1 block. And then how do we do blocks on top of that?
We do more relative coordinates, except 1, 2, 3.
Yep. And we start building up on top of the Y to go through. And so this program was pretty straightforward. It's mostly just this after we connected into Minecraft. Turn back around. But on this, we learned a couple of important pieces. The relative location comes up over and over again in all of our programs as it went through. But there was a key element. We went with a 3-block high stack, and I made Alex type out all of that code. And then I asked him, what if I asked you to make a 50-block high stack? What did we learn?
We learned that would be a lot of typing, and he made me do the typing.
I did indeed make him do the typing as it went through. And so if you've done any programming, you probably have run into this issue yourself. And so we decided to dive into the next one, and we were going to build a wall and learn some efficiencies inside of our program. And so for this one, we wanted to build an actual structure. So we can see a picture of it here, but Alex is going to use his Rubik's Cube to explain what we wanted to build for this. And so we've got our character. Here, I'll help you hold it, and you can point.
Okay.
We've got our character, and he's right in the middle of his world. And what did we want to do? Where did we want to build?
Want to place brick blocks right here, 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 and right here.
Yeah. So we wanted to surround our player with blocks. That was the goal as we went through. And so rather than jumping right into code, which is an important skill to go through, we set out to do some planning. And this is the actual piece of paper we used to plan out this program as we went in. And so inside of there, you can see it, we've pointed out. And what did we create on our planned paper here, Alex?
We created a list of relative coordinates. Yay!
And he picked up, I didn't even have to prime him the first time he did this. He knew it was a list. And lists are another really important thing in Python. Lists let us do all sorts of interesting things. And so when we were working on this program, it was just about lunchtime. And so before we dove into it, I decided to break off the Minecraft for a minute, and we went into peanut butter and jelly sandwiches. And so we came up with a list of the ingredients that go into a peanut butter and jelly sandwich. How did we create our list, Alex?
So we had to use square brackets.
Mm-hmm.
We needed quotation marks and commas.
Yep. And that put together our list of the sandwich. And then down here, when we printed out, and once again, I made him type all of this code, how did we print out the different ingredients? What numbers did we use, let's say, for the first piece of bread?
Starting with 0, not 1, 0.
Exactly. Now, we've done some coding before, and we went through this, so he was familiar with counting from 0, but that continues to be one of those challenges, even for me as kind of an adult programmer going through, remembering that we count from 0 as we went in. And so we dealt with the list pieces. But the real important part of this, what we were really after, was down here at the bottom, the for loop. When we got to the for loop, Alex, what was the value of the for loop?
The variable for loop is so you don't have to type everything over and over again. And as a joke, the for loop, I call it a for loop because there's 4 things. Yay!
That's pretty good. He deserves applause. He's been saving that because that's the first time he's used that joke. Well done. And so we took all of the skills that we had, that we learned here after lunch, and we built our program to build the wall. So let's see the wall program in action. Switch over here. And so Alex is going to go ahead and run our wall program. Oh, he's going to cheat, too. And so there we can see as it paints through off of my other computer, we've now surrounded our character with a wall and a very efficient piece of code and program as we went through. I think it deserves an applause, yeah. All right. And so we tackled this one. It was a fairly quick one. We didn't do a whole lot of differences from our Bedrock stack, but we continued to learn lots of new important programming skills. We learned the importance of planning. We all know you can't immediately jump into code when you want to go through. You have to start out understanding what you're trying to accomplish. We dove into the relative positioning and spent a lot of time on that because we need to use relative positioning. Alex, why do we have to use relative positioning?
Because if you don't use relative positioning, you need the X, Y, and Z real coordinates. That would be real numbers instead of that.
Yeah, and you don't know what the real numbers are, right? Your player can walk anywhere in the world. You have no idea what those are, but we can always base things off of where we're currently standing. We learned about the lists. We learned from counting from 0 that went through. Tons of really good, important programming pieces with this basic one. But for our final program for our presentation today, we wanted to do something that was actually interesting, valuable for our up-and-coming Minecraft player that was here. And so we wanted to build what?
we want to make an emergency shelter.
Exactly. So let's explain to everybody, if you've never played Minecraft, the value of the emergency shelter. What do we need the emergency shelter for?
So the emergency shelter, if, let's say you're wandering around at night, googlies come out or monsters, you have to have the materials to make your house, block by block by block, placing it again and again and again and again.
And it's time consuming. If you've ever played Minecraft, you've got to chop down trees, you've got to mine stone, you've got to build things, and that takes away time from the interesting stuff like exploration and all the other pieces. And so we said, could we actually build a pocket emergency shelter in
Yes.
code? Oh. He's jumped right to the end. No spoilers, but yes, you can actually build one. And so once again, we did our planning. Now, we went to a purple whiteboard, which is a bit hard to see on the screen, but it's a purple whiteboard we used to do all of our planning for this. And so for this, we're going to use a couple of our Rubik's Cubes here as visual aids. And so move over a little bit. Inside of the Minecraft library, there's a lot of functions. We used the set block function to place one block at a time. There's a set blocks function that lets you build entire cubes or rectangular shapes of what's out there. And so we can build all at once, lots of blocks at a time. For that, let's say we wanted to build this nice 5 by 5 by 5 cube of stone. What information do we need to know to build this cube?
The two corners, one right here and one right here.
That's right. You just need to know the coordinates of the opposite corners that are there. And so with that, we can very quickly stand up a secure block of stone. But it's a solid block of stone, not terribly useful if you want to walk inside it. So what did we need to do inside of that block of stone?
Make an air block. Remember, two corners.
Yep. So 2 steps. First, we build our block of stone, and then inside it, we put a 3 by 3 by 3 block of air that went through. And so that was the big part of our planning, was figuring out those relative coordinates for the blocks. We also wanted to add some homey touches. I asked Alex, when you're building a shelter in Minecraft, what do you usually put inside of that shelter? What was our list?
Bed, a chest, crafting table, and a torch.
Right. So make it super easy to go through. So we planned all that out on our whiteboard, and then we built our code for it. And so inside of here, we're taking advantage of those functions. We drop our character. And so we can see these set blocks is where we're building our cube. And inside of there, what are the 7 pieces of information? What are those for? Down here inside the set blocks, what are these 7 pieces of information?
This first line is the first corner, and then that's the second corner, same as down here. This is cube, this is air.
Yep.
Then, as you can see.
Yep. And then on the second piece, again, same program, just in a different slide, we go ahead and we put out our homey touches into it. Now, there was something interesting we had to troubleshoot as we went through here. Explain, what did we have to figure out when we were building the door, Alex?
So, it was kind of hard. We had to Google it.
Another important programming skill is the use of Google.
Because it's the positioning. So it's like, a door and a bed take up 2 spaces, so you need 2 pieces of code for each one. So first we did all the routes of coordinates, then we did door, wood, we all know. And then we need to use one for the right position and the bottom half.
Exactly. So what you see here is the door wood ID. That's the same block ID, whether it's the top of the door or the bottom of the door. The part that Google helped us out with is that second piece, the 1 and the 9. And that was which type of door. Was it a top of the door? Is it a bottom of the door? Is it open? Is it closed? And that was something we just had to experiment with, one number at a time, until we figured out what actually made the shelter the way that we wanted it. And then the same thing happened with the bed. Beds also take up 2 blocks, and they have a bottom half and a top half where the pillow is that went through. And then the rest of it was pretty straightforward, just dropping in what we wanted. So let's see this program in action as well. All right, so we're here. Go ahead and run our shelter program, Alex.
Okay.
We We also taught a little bit of Bash 101 with the up arrow as we went through. And so as he goes and does that, you can see that we now have a nice shelter with the bed available for going ahead and using. Oops, get our move. There's the bed in the corner. So we see our bed in the corner. Pretty nice. Now, is that faster than chopping down trees and mining for stone?
Totally.
Exactly. When we built our first shelter this way, he was super surprised, and the awe hit his face because he realized one of the important things of programming finally as we went through. Most of everything else that we had done up to this point was, yeah, I can put a block, I can do that. But we actually saw that we can make super cool and useful stuff inside of the programs. And he wants to have that whenever he's playing now as we go through. There were other things that we learned in this one, the importance of adapting. If you've ever coded something before, how many times have you built a plan and then it immediately worked exactly as you thought? Yeah, like never works that way. So being able to adapt as you go through. And then one of my favorite parts of this program, because once again, I made him do the typing. And you can tell for sure, because I snapped a picture as he's there looking super thoughtful, because he ran the program and got a syntax error. And he had to look for it. And what were we missing in our syntax error?
A comma.
Yep, a comma. And I told him everybody misses. So help me out here. How many people have had to go on a comma or quote hunt in your code before? I told you. Everybody goes through it as we go in. And so we had a lot of fun building these programs. And we've got lots of other ones that we plan to do as we go through. But if you're interested in doing some of these other pieces, a couple of suggestions. Now, the first and foremost suggestion, and I've talked to a lot of people this weekend already, is this book. It's the No Starch Press book, Learn to Program with Minecraft, and it's focused specifically on Python. It is an excellent book. I've read it kind of cover to cover at this point. He's gone through a lot of it, and it provided the inspiration for a lot of the projects we went through. One of the other things that was nice about the book is it walked through what it took to set up Python and Minecraft so that you could jump in. Now, it's not that hard to get started. If you've got a Raspberry Pi at home, you can do this immediately as you go with no extra cost, because you can put a Minecraft version on a Raspberry Pi, and all this Python stuff initially was from the Raspberry Pi. And then some folks took that and then open sourced the code to put a server on top of the full PC and Mac server platform that's there. All of the information on how to set that up is in the book. Right? I didn't have to be a master at Java, because that's actually why I left programming originally, is I didn't like Java. Yeah. And so I cheated, and I went back and I used his information and stood it up really quick as it went through. Now, also on that, there were some handy sites. So MCPI, that's the actual Python SDK that's in use for that, and it's up on GitHub, like everything else that's worth looking at these days is up on GitHub. And so you can find the code that's up there. Raspberry Juice is the piece that actually plugs in from the Java servers that you can actually code against. That's all up on GitHub as well. And the code examples for all of the programs, the ones we demoed as well as a few other ones that we built along the way, are all up on my GitHub as well. I'll tweet a link. I've got these slides up on SlideShare, and I'm going to see if I can get the PyOhio people to put a link right in the description for this so everybody can get the slides that are there. We are just about out of time, so we wanted to say
Thank you.
thank you, everybody.